here we are. This is just a quick demonstration of how you would calculate standard deviation. You don't actually have to do that for any of these problems, but I want you to understand what it means. Again, the higher your standard deviation, the more spread out your data is. So let's come back to our problem. All right, we had Tucker School that had a mean of 38 inches, and the standard deviation we said was 6. Now, whether or not you realize that that's actually enough to come up with an accurate guess of how many people are going to be less than 50 inches tall. Right here, this chart that I passed out, this is going to be your best friend for the next couple of days. Meet the normal curve. And it's a shame that's not title on there, so if I were you, I'd go ahead and write it on the sheet. This is what we call the normal curve. You ever heard of the term such and such has a normal distribution? Kind of, sort of. There's this phenomenon called the normal distribution, which means for certain things in this world, not everything, but for certain things in this world, if you measure them enough times, you're going to end up with a shape that looks like this. Perfect example, flipping a coin. If you flip a coin 100 times, how many times would you expect to get heads? You expect about 50, right? So if you did 10,000 trials of flipping a coin 100 times, most of those 10,000 times, you're going to be in here around 50. Now, every once in a while, you might end up with 99 heads, right? That could happen, but it's only going to happen like a very small percentage of the time. So that's why as you get away from the mean or what you expect to happen, 50 flips, as you get away from that, it's happening less and less often. But the mean, the average, which you would expect to be 50, right? If you flipped it a bunch of times, your average would eventually come out to be 50 heads. Your mean is going to be represented here in the middle. So the idea is, the closer you are to the mean, the more likely it is going to happen. The closer you are to the mean, the more likely it is that that event's going to happen. Now, look at all this stuff at the bottom. Look at all these symbols we got going on here. Notice what's always in the center right there, mu. That's the mean. If you want, you can go ahead and label that if you forgot. Your mean is chilling in the middle. What the normal curve says is that it doesn't matter if you're talking about flipping coins. It doesn't matter if you're talking about heights of students, if you're talking about wingspans of butterflies. For anything that's normally distributed, if you're within one standard deviation on either side, you can expect that to represent 68% of the population. Doesn't matter what you're talking about, as long as it's normally distributed. If you're within one standard deviation on either side, then you can expect 68% of the population to be there. That's a sigma, right? Now, if you're within 2 standard deviations, you're talking about 95% of the population, and if you're within 3 standard deviations, you're talking about almost everybody, 99.7%. This right here is what you have to take away from me today. It's a little something called the empirical rule. And whoops, empirical rule. Basically says these percentages right here. For normal distribution, if you're within 1 standard deviation from the mean, expect that to represent 68%. And if you're within 2 standard deviations, then it's 95. So with our problem, okay, and if I were you guys, I wouldn't write on the little sheet that I gave you for our problem, because you're going to want to reuse this normal curve, right? But for ours with Tucker School, remember we had a mean of 38 and a standard deviation of 6. So what I always like to do is do a real quick sketch of a normal curve. It doesn't have to be perfect. You're just using it as a guideline. Right in the middle is the mean, which we said was mu, in this case, is 38. And now each line on your curve is represented by a standard deviation, which, since we said the standard deviation was 6, the next line would be what? If I'm counting by 6, 44, right? I'm counting by 6s. Yep. Next line would be 50 and then 56 if I'm going this way. Next line would be 32, 26, 20. Now, let's just practice using this normal curve for a second. If I asked you what percent of students are in between 32 and 44 inches tall, using the empirical rule, here's your 32, here's your 44, what percentage of people do you think we're talking about? If I asked you between 32 and 44, 68%. If I asked you what percentage of students are less than 38 inches tall, here's the 38. Less than 38 is everybody down here. What percentage of the curve is that? 50. That's 38, splits it in half, right? If I said in between 26 and 50 inches tall, what percentage are we dealing with? 95, right? You see how my curve lines up with the template. Now, our job is to figure out how many students are less than 50 inches tall. Can you see how you're really asking about let me try that again. You're asking about this piece of the graph. Right? I want to know what percentage of the graph is over here. Now, it's nice because we know what half of it is. So we know over here I got 50%. So now, really all I got to do is figure out what's happening with these two sections. Okay? And that's just a little bit of math. It's not too hard to figure out. I mean, you can just look at it and say, hey, if this section in the middle is, and they kind of have it broken down for you here. That's worth 34, that's worth 13.5. So then you know it's 50 on the left side, plus the 34, and the 13.5 is what? 47.5. I'm not going to worry about that 13%. So over here, I really got 47.5% between these two together. So you're really talking 97.5% of people you can expect to be less than 50 inches tall. Yeah, that's what I'm saying. If you get, like this is very specific with the 0.13 and all this kind of stuff. Really, just use the 68 and your 95 and your 99.7 as your guidelines. So like if you think of between here and here is 68, half of 68 is 34. So this section is worth 34. Right? Don't worry about the 0.13. Okay? And then if you know between 26 and 50 is really 95%, take off the 64, and now you're down to 30, 35. Yeah. 68%, 95, yeah, 35, sorry, 25. That was not right. 27. So then between these two guys, you know there's 27% cut in half, and that means each one is worth 13.5. So then you can just add up the grade. Alright? So there's the answer to your question. You can expect 97.5% of the students at Tucker School to be less than 50 inches tall. Qué fácil, ¿no? Check it out. Once you figure out how to read this graph, these problems become so easy. Let me give you an example of what you're going to see in the homework. What's up, Taylor? Is the graph going to be on the test? You are going to have to generate the graph, right? So what I would do is, what you need to memorize is 68, 95, 99.7. That just need to memorize, right? Now, right now, I gave you that little graph to kind of help you visualize it. But that's what you need to memorize. So, for example, this is what you're going to see on the homework. Example 2. You're just going to see some mess like this. P, X, less than U plus. That's what you're going to see. Now, that looks like a foreign language, doesn't it? Right. All that's saying is find the probability, that's what the P stands for. What's the probability that a random value for a normal distribution is less than the mean plus a standard deviation? So again, if you look at your little chart, or you can sketch one of your own. Here in the middle is the mean. Here's one standard deviation. Right? And that's actually what it's asking us for, the one standard deviation. So all you got to figure out, if it's less than mu plus standard deviation, then it's really just talking about this piece here. Well, again, you know half of it is 50%. We know that the space in between one standard deviation either side of the mean is 68. So what does that mean this little section is? From here to here is 68. So that means just this piece right here is going to be the 34. So you got 50 over here, 34 over there. So the probability that I'm going to be less than one standard deviation above the mean, 84%. That's it. The 34 I got because the empirical rule says that between one standard deviation from the mean, it's 68. Right? That's what the empirical rule says. Well, this splits it in half. So I got half over here and half over there. So then this half between the mean and the first standard deviation is worth half. How much?